Okay, now we'll discuss the solution for the third question in the mid-semester examination. Bus 2, the load center, is a city that sometimes needs as much as 1000 megawatts of power, but currently needs only 800 megawatts. To meet its load, the city has 500 megawatts of generation and a 500 megawatts power line connecting it to the remote bus 1, where there is more than 500 megawatts of available generation. Many small generators with different variable costs are located at each bus. The cost of generation in the city starts at $40 per megawatt hour and increase at the rate of $2 per megawatt hour for each additional 100 megawatts of output. The situation at the remote location is similar, except that the cost starts at $20 per megawatt hour instead of $40 per megawatt hour. Now we'll see here at the city bus, that is at bus 2, the demand is 800, and at bus 1, that is the remote bus, at the remote bus the demand is 100 megawatts. This is a 500 megawatts line. That means the limit is 500 megawatts. The line limit is 500 megawatts. Now, as per the question, the generation cost of both the city bus and the remote bus are given here, $40 and increase at the rate of $2 per megawatt hour and 100 for each additional 100 megawatts of output, and here it is $20 and the same situation. So the expression for incremental cost is given. Incremental cost at remote bus is given $20 plus PG1 minus 100 divided by 50, where PG1 is the power generated by generator 1, and at the city generator site, or at this particular location, the incremental cost is $40 plus PG2 minus 100 divided by 50, where PG2 is the generation from generator G2. Now you are asked to determine the locational marginal price at remote bus 1 and city bus 2. Let us see uh, what is happening here. So initially the loads are 800 and 100. So the total load is 900. And comparing these two incremental costs, you know that this is the cheaper one. That is the incremental cost at bus 1 is the cheaper one. 20 plus PG1 minus 100 by 50. This is 40 plus PG2 minus 100 by 50. So out of these 900, maximum power should be contributed from bus 1, right? The cheaper generator is bus at bus 1. So here 800 is there, here 100 is there. Now here there is a 500 megawatts limit, right? So 500 can only be taken from bus 1. So 500 will come from here, and remaining 300 will come from here. Okay, remaining 300 will come from here. So 500 has to be generated by the generator at bus 1 for satisfying the load at bus 2. And there is a local load of 100 megawatts at bus 1 also. So 500 plus 100, 600 megawatts should come from generator 1 and 300 megawatts from generator 2. And the line has already hit the limit. So when substituting this 300 in PG2 and 600 in this PG1, you will get the locational marginal price LMP for bus 1 and bus 2. That is 20 plus 600 minus 100 is 500. 500 by 50 is 10. So 20 plus 10 is $30. $30 is the LMP at bus 1. And here it is 40 plus 300 minus 100 is 200. 200 by 50 is 4. So 44. 40 plus 4 is 44. $44 at bus 2. That is the LMP. So bus 1 LMP is $30 and bus 2 LMP is $44 per megawatt hour. Now to find the congestion charge, it has already hit the limit. Now for any increase, there is a congestion. Any increase in line flow, there is a congestion. So there must be a congestion charge. To find the congestion charge, you need to take the difference between the LMPs into the actual flow, right? So the actual flow is 500 megawatts through the line. the LMP here is 44, and for the other bus it is 30. So 44 minus 30 into 500. 44 minus 30 into 500 has to be taken. Now I think this is wrong. This is 44 minus 30. This is the second part of the question. Congestion charge based on short run marginal cost. So this is 14 into 500. That is 7,000. Okay, this is not 40, this is 44. Now in the third part of the question, repeat 3.1 and 3.2 if the city demand drops to 400 megawatts and remote demand drops to 50 megawatts during off-peak hours. That means this 100 has become 50 and this 800 has become 400. Now the total demand is 450, right? Now the total demand is 450, 450, 450. So this 450, again comparing the incremental costs of these two regions, this one is the cheaper one. Bus 1 incremental cost is the cheaper one. So actually speaking, the whole 450 can be satisfied by bus 1. But the problem here is at bus 2, the generator has a minimum limit of 100 megawatts. So at least 100 megawatts should come from bus 2. So out of 450, if 100 is coming from bus 2, then 350 should come from bus 1. So if this is 350, this PG1, if we substitute it as 350, then 350 minus 100 is 250. 250 by 50 is 5. 20 plus 5 is 5. $25 is the LMP at bus 1, or the remote location. Remote locational marginal price is 25. Now, what happens to the locational marginal price at bus 2? Currently, the load is 400 megawatts. For the next increment in load, from where the power will come, whether it will come from bus 2 or bus 1, it should come from bus 1, because it is only 450. The current generation is only, no, the at present the generation is only 350, right? At present the generation is only 350, and more power capacity, remaining capacity is there for the generator to generate more. Also the line has not hit the limit, so more power can be taken from this side, and that is a cheaper one. So for any increment in power at bus 2, this extra power should come from bus 1, so that LMP should be used. This incremental cost, this the expression for the LMP at bus 2 should not be used here. This should be used. So the same LMP will apply here also, bus 2 also. That means 25 is the LMP at bus 1, 25 is the LMP at bus 2 also. Now there is no congestion, right? It is below 500 now. So for congestion charge, we'll take 25 minus 25 into 500, which is $0 per hour, right? $0 per hour. So this can be anything actually. If it is 500, if it has hit the limit, then we will take it as 25 minus 25 into 100. Now I think at present it is only 350, right? Not 350, here it is 400. 100 is coming from here. This is only 300, right? 300. So this is actually 300. 25 minus 25 into 300, which is $0 per hour. So that is what is a solution for question number 3. Thank you.